So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over and continuing with Pythagoras' theorem with a focus on 3D Pythagoras problems. Now we use Pythagoras' theorem to find missing sides on right angled triangles. However, right angled triangles appear inside a 3D shape, allowing us to find other lengths on the 3D shapes, and more commonly the diagonals in prisms and the slanted side in pyramids. Now if we look at the cube that you can see on screen, that the longest length, so in other words, if a question was asking me what's the longest stick that could fit, or pencil, or whatever this cube represents, what is the longest length that I could fit inside this cube, then that would either be C to H, so H to C, or C to H, whichever, they're both the same thing. It would be D to G, it would be A to F, and E to B. And these would all represent the longest lengths inside the cube. Now you may be thinking, well, where do we see this right angle triangle? Well, if we look at H, now hopefully we all agree that each of these four lengths are going to be exactly the same because they're just going from one opposite end. So all of these are also the same length from this cube. So what you need to spot is that this here is going to be a right angle triangle. So that triangle of E, H and C is a right angle triangle, and this here is also going to be a right angle triangle, where this here is our 90-degree angle. And so you can see how this turns into, let's say, like a two-stage Pythagoras question if we're asked to find the longest length or the diagonals from one end to the other of this prism. So let's have a look at an example, or a common example, where we're asked to use 3D Pythagoras comes into play. So it says that this diagram shows a 5 by 5 by 5 centimeter cube. Calculate the length of the diagonal AB. Give your answer correct to one decimal place. Now the key thing to note is that A and B, the only two vertices, are labelled, but again it could be either opposite angle in terms of vertices, and it'll be the exact same length. Now for this, what we need to do is recognise that this is a two-stage Pythagoras question. So if I take the triangle that AB is connected to, and we'll call it our blue triangle, then, and I just take that out of the shape. So this is A, this is B, which is what I want, so I'm going to call that X. And I don't know, I know this length here is 5, but I don't know what this length here is, which is why I'll be unable to use Pythagoras. However, if I take another right angle triangle, which is basically looking at this purple length, which is what I'm wanting, I can use this right angle triangle to work out what B to C is. Now if I just label that C, so what we need to do is we need to find BC first. Now to do that, if I take that sort of maroony colour triangle out, that this is 5, and B to C is what I'm wanting. So here, to find B to C, again labelling the triangle, so this is going to be C, that's going to be A, that's going to be B. So here BC squared is going to be equal to 5 squared plus 5 squared. So BC squared equals 50, and then BC equals the square root of 50. Now with this, what I can do is I can, from this triangle, if I just bring this triangle over here so we've got a bit more space. So BA is what I'm trying to find, so that's X. This is 5, and I know now that this length here is root 50 centimeters. So here, using Pythagoras again, I've got X squared, let's just label this, so this is C, that's A, that's B. So I've got C squared is going to be equal to 5 squared plus root 50 squared. And from this, I've got X squared equals 25 plus 50. So X squared is going to equal 75. So X equals the square root of 75, and type that into my calculator because the question wants me to write it to one decimal place. So let me just get my calculator out. So here we've got root 75, press equals, gives me 5 root 3, or it gives me 8.7 centimeters to one decimal place. And there's my final answer. Moving on to our second example. So this time here what we've got is we've got a cuboid, But again, the method is exactly the same. So here, if I draw this triangle here, so that's the triangle that has actually involves A and B. So again, if I just label this side C, so I've got B, got A. This is 5 centimeters. Oh no, it's not. That is something I don't know. And the only thing I do know is that this is X, which is what I'm trying to find. And I know that this is 7 centimeters. And this is something I don't know. So what I need to do then is find out what this line here is first. So find BC. So again, taking that triangle out and just labeling it BC, just call that D. Then this length here is 6 centimeters, this is 5, and this is the side that I'm wanting, which I'm just going to call Y. So from this, what I've got is I've got Y squared equals 6 squared plus 5 squared. So Y squared equals 36 plus 25, which then gives me an answer of 61. So Y squared equals 61. So Y equals square root of 61. So now I can, BC is going to equal root 61. So from this triangle here, I've got x squared equals 7 squared plus root 61 squared, in which from this, the square root cancels with the square. So then what I'm left with is x squared equals 49 plus 61. So x squared equals 110. So x equals the square root of 110. And the question again is asking me, giving my answer to 1 decimal place. Let's get the calculator back up and do the square root of 110. This equals, and it gives me 10.5. So x equals 10.5 centimeters to 1 decimal place. So moving on to our next question. So this question here involves a triangular prism, and it says the diagram shows a wedge in the shape of a prism. Angle BCF is a right angle. It says a string runs diagonally across the wedge from A to F. So let's first of all do that, and this is the length that I'm actually trying to find. So the length of A to F. Now if I turn that into a right angle triangle, that's what it's going to be, and it doesn't quite look like it. So this is A to F is what I'm trying to find. So let's just start by calling that X, and the only length of that triangle I know is A to C, F to C, which is 5 centimeters. So I don't know what this length here is. However, if I look at the second triangle to find that involves A to C, which is that triangle there. So if I take that green triangle out, A to C is what I'm wanting. So let's just call that Y, and I've got this is 15 and this is 11. So from this I've got Y squared equals 15 squared plus 11 squared. So Y squared equals, and again just grab the calculator to write that in, so I've got 15 squared plus 11 squared equals 346. So Y equals the square root of 346. So on this diagram here, I'm just going to write that as 346. Now one thing you may note is that I'm not actually working out the decimal answer of root 346, and the reason for that is because this can appear on a non-calculator paper, and I'll show you how this all works with that. So if I take that triangle out, so let's just do a little sketch of the triangle AFC. This length here is 5 centimeters. A to F is what I'm wanting, and this answer here is the square root of 346. Well, the reason why I don't write 346 as a square root of 346 as a decimal is because you're only really supposed to round up your final answer, and obviously I may lose accuracy if I give that length to 1 decimal place or 2 decimal places. So, and also it's easy for me to then work through the next stage. So looking at Pythagoras, I've got 5 squared plus the square root of 346 squared. And again, the square root cancels with the square. So what I'm left with is that x squared equals 25 plus 346. And if I add those two numbers up, I'm going to get 371. And then so x equals the square root of 371. So if I want to leave my answer as a third, then that's what I'll do. But the question's asking me to write the answer to 3 sig fig. So on the calculator, square root of 371 equals, and I get an answer of 19.3. So x equals 19.323 sig fig, and the units are centimeters. And there is my final answer. So moving on to our next example. So this involves a pyramid. So it says the diagram shows a 7 by 6 rectangular base pyramid. The diagonals TA, TB, TC, TD are lengths of 10 centimeters, and M is the midpoint of rectangular base. And the question is asking me to work out M to T to 1dp. Now for this is going to be quite a high level question, only because we're not actually wanting to work out what any of the diagonals are. Now the first thing I'm going to do is I'm going to take, so the blue line is what we're trying to work out. So if I take this green triangle, which I didn't really complete, so let's just do that and just label the size, so A, C and B. So this is 7, this is 6. I want to work out what A to C is. So x squared equals 6 squared plus 7 squared. So that's going to be 36 plus 49, which gives me 85. So x squared equals 85, so x equals the square root of 85. Now from this, that if I then take this blue triangle, I need to know two of the lengths. Now A to M is half of this, so M is here. So all of this is root 85, then half of that is going to be half of root 85 over 2. So looking at that triangle there, what I've got is I've got 10. This is what I'm looking for in terms of M to T. And this length here is going to be root 85 divided by 2. So then using Pythagoras for this, I've got 10 squared equals x squared plus, and then root 85 over 2 squared. And again, if I wanted to work that out, that's absolutely fine, but I'm just going to leave it as it is. So here I've got 10 squared minus root 85 over 2 squared equals x squared. So x equals the square root of the answer, which if I type into my calculator now, let's have a look what we get. So I get the square root, or no we don't, we get 10 squared minus, and then bracket, root 85 divided by 2 squared equals, so it's 315 over 4, and then if I then square root that, I get an answer of 8.9 to 1 decimal place. So x equals 8.9, and it's centimeters to 1 decimal place. Now if I wanted to in terms of here, so x equals, and then as a fraction, did it give me as a fraction? Yes it did. Let me just square that so we get what x squared was. 805, so x squared equals 315 over 4, so x equals the square root of all of that if I wanted to give it. But again, because the question is asking me to give it to 1 decimal place, this would be my final answer. So let's have a look at another question. So again, this is very, very similar, but this was taken from an actual exam paper and was actually worth 3 marks. So not really that generous in terms of how many marks are on offer, but this one is worth 3. So for this, it's asking me to work out the length of the pool cue. So it says a cupboard is in the shape of a cuboid. A pool cue will just about fit in the cupboard if it's placed diagonally as shown. And the question is just asking us to work this out. So what I need to do first is I need to work out what this length here is. So to work that length out there, what I've got to do is treat that triangle, which has got 60 by 80. So find this length out, which I'm just going to call x. So I've got 60 squared plus 80 squared equals x squared. So x squared equals, then on the calculator, I've got 60 squared plus 80 squared equals, and that gives me 10,000. And so x equals the square root of 10,000, which is going to give me a decimal answer. On it goes to 100. X equals 100, of course it. So this length here then is 100. So then taking that second triangle out, so here I've got A, B, and whatever this is, we'll just call it C. So then this length here is 100. This length here is 120, and that length there is what I'm trying to find. So here I've got x squared equals 120 squared plus 100 squared. So x equals the square root of all of that, so 120 squared plus 100 squared. If I just type that into my calculator, let's have a look what we get. So we get square root of 120 squared plus 100 squared, and we get an answer of 156.2. So x equals 156.2 to one decimal place, and that's in centimetres. Now, does that answer look correct? Well, I would say so. It's definitely longer than 120, which is the height of the cuboid, and so yeah, that should be absolutely fine as my final answer. So in our final example, it says here that a pencil case is in the shape of a cuboid as shown. A pencil has a length of 15 centimeters. Will it fit inside the pencil case without breaking? So what we need to do is we need to work out what the diagonal length of this particular cuboid is. Now I'm going to start by actually labeling the vertices, just so that it just helps in terms of you understanding. However, in an exam there'll be no expectations for you to do just that. If anything, it may just help you in terms of your working out. So here I've labelled all the four edges, and the longest length is, as an example, will be going from the opposite corners. So I'm going to be looking at here of B to H. So what I need to know is I want to know the length of that blue line. But again, it's going to be very difficult for me to find that out, because if I turn that into a right angle triangle like so, that here I only know what one of those lengths are. So this is what I'm trying to work out. This is what I've been given, and I need to know what this side here is going to be. So first things first, I need to work out what BG is. So if I just take that triangle out and look at this base triangle. So in terms of this base triangle, what I've got is I've got B, C, and G. This is 6, this is 12, and I need to work out what this is here. So looking at this triangle here, I've got that y squared equals 6 squared plus 12 squared. So y squared equals 36 plus 144, which is going to give me 180. You dot fans. And then so y equals the square root of 180. So this length here is now square root of 180. So then if I take this triangle, so let's take this one here, let's just do that triangle again. So I've got B to G to H. G to H is 5 centimeters, B to G now is 180, and B to H is the longest length. So working out what x is, x squared equals square root of 180 squared plus 5 squared. So that's going to give me x squared equals 180 plus 25. So x squared equals 205. So if I then square root 205 on my calculator, so let's just get that calculator out. So we've got square root of 205, press equals, gives me an answer of 14.3. Now this is a complete utter mess, so let me just move this over here. So here x equals 14.3 centimeters to one decimal place. And let me just double check on the rounding. Yep, 14.3. So the answer which I've not answered is no, the pencil will not fit. And it's always important that you do make that statement, because the question is asking you whether the pencil will fit. Clearly you will not get all the marks if you just wrote no or yes. You'd have to show some working out, and exactly the working out I've shown here would be exactly what they're expecting, obviously much neater, going in a nice little flow rather than all over the shop.